Hello everyone, in this video we are going to talk about the various isomers of C4H9Br and then we will talk about isomerism among these structures. Let us first determine the degree of unsaturation for this elemental composition. Degree of unsaturation for this elemental composition is equal to 1 plus number of carbon atoms minus number of hydrogen atoms by 2 minus number of halogen atoms, that is X, by 2. Therefore, this is equal to 1 plus 4 minus 9 by 2 minus 1 by 2. So, therefore, 5 minus 4.5 minus 0.5. Therefore, degree of unsaturation for this elemental composition is 0. This means that we do not have to worry about carbon-carbon double bonds or rings. Everything is saturated. Let us write the isomers one by one. I will first write the isomers in condensed form, then I will write it in bond line notation. So, number 1 Br and then CH2 and then CH2, CH2, CH3, 1, 2, 3, 4. So, this is 1 bromo butane and the corresponding structure in bond line notation is bromine and then 1, 2, 3, 4. So, that is 1 bromo butane in bond line notation. And then number 2, we can also write 2 bromo butane. So, therefore, that is CH3, CH, Br, CH2, CH3 and the corresponding structure in bond line notation will be 1, 2, 3, 4 and then bromine at 2 position. So, this is 2 bromo butane. Now, there is something special about 2 bromo butane because we have a asymmetric carbon, we have a ethyl group, we have a methyl group, we have bromine, we have hydrogen. So, therefore, this carbon, that is carbon at position 2 is chiral, that is the asymmetric carbon. This means that 2 bromo butane has 2 isomers. In terms of constitutional isomers, you can say it is 1 isomer, but because it has an asymmetric carbon, in terms of stereoisomers, we have 2 isomers. So, let us write both the isomers. So, 1 we can write it this way, 1, 2, 3, 4, let us say bromine is towards us and then another isomer that we can write is this one, 1, 2, 3, 4, let us say bromine is away from us. Let us assign the absolute configuration. As per Cahn-Ingold-Prelog-rules, we know that bromine will get the top priority because atomic number of bromine is higher than atomic number of carbon. And then the hidden hydrogen here will get the least priority and then the ethyl group will get the second priority and then the methyl group will get the third priority. Why we are choosing ethyl group second priority is because this is connected to 2 hydrogens and then carbon here once again. But here the point of difference is that this is connected to a carbon, but when you see in terms of point of difference, then this is like 2 hydrogens and then again hydrogen, but that is not the case for the ethyl group and therefore, we have to give second preference to the ethyl group and not the methyl group. So, let us convert this into Fischer projection. Bromine is towards us, so therefore, that is 1, hydrogen is here, 3 on top and 2 on bottom. We can't assign absolute configuration this way. So, let us bring the 4 down. We have to put the least priority group down to assign the absolute configuration. So, therefore, 1 here, 4 here and then 2 here, 3 here. So, this is counterclockwise. So, therefore, this is yes. This means the original is R because we did one swap. So, therefore, this is R. Therefore, the correct IUPAC name for this structure is, including absolute configuration, it is 2R, which we have to write it in parenthesis, 2R bromo butane. Since this one is R, the other one has to be S because we have only one chiral carbon. So, this is 2S bromo butane and 2 and 3 are enantiomers, mirror images that are not superimposable. Now, let us go to the 4th isomer. We discussed 3 isomers so far. We can also write 1 bromo 2 methyl propane, that is CH3 and then CCH3 and then CH2Br. So, 1, 2, 3, So this is 1 bromo 2 methyl propane. And then number 5, we can also write 2 bromo 2 methyl propane, and that is CH3 C CH3, and then at the same position Br, and then CH3 1 2 3. Either way we can number it for this case. So this is 2 bromo 2 methyl propane. We are writing bromo first because as per alphabetical order it should come before methyl. So that's why we are writing the bromo substituent first. So for number 4, the corresponding structure in bond line notation will be 1 2 and then 3, and then there is a bromine here, and then at 2 position there is a methyl group. And for isomer 5, the corresponding structure in bond line notation will be 1 2 3 and then 1 methyl group and then 1 bromine. Now let's talk about isomerism. As we already said, 2 and 3 are enantiomers, non-superimposable mirror images. How about 1 and 2? If we are comparing 1 and 2, then we have to call them as position isomers, because the bromine position is at different places. In 1 it is at 1, in 2 it is at 2. 1 and 3 are also position isomers. How about 1 and 4? If we are comparing 1 and 4, then what kind of isomers are they? They will become chain isomers because the chain length is different, isn't it? The parent chain length in both the cases are different. How about 1 and 5? 1 and 5 are also chain isomers. Okay. How about 2 and 4? If we are comparing 2 and 4, then they will become chain isomers once again because the chain length itself is different. How about 2 and 5? 2 and 5 are also chain isomers. Parent chain length is different. How about 3 and 4? 3 and 4 are also chain isomers. 3 and 5 are also chain isomers. How about 4 and 5? If we are comparing 4 and 5, then they become position isomers once again. Why? Because the chain length is same now. It's only the bromine position that is different. Even the methyl group is at the same position. We have a methyl group at position 2 in both 4 as well as 5. It's the position of the bromine that is different in both the cases, isn't it? So here it is at 2, here it is at 1. So therefore they differ by position. Therefore 4 and 5 are position isomers. So if the question is being asked how many constitutional isomers are there for C4H9Br, then your answer should be 4. But if the question is being asked like what is the total number of constitutional plus stereoisomers, then your answer should be 5.